So now, how is Frew used? I mean, a lot of people, we've often been asked how is Frew used internally and externally, and and to show really the value of Frew. And I've chosen 3 case studies, and due to our limited time, I can only cover them very briefly. But some case studies are available on the website, and you can read them in more detail. And case studies will be made available over time. So I'll start with a case study from one of our external customers, which is Van Earl. And this case study was actually presented at the Deep Foundation Institute. And it's a case study showing how novel solutions were modeled for a roll-on, roll-off ramp retaining wall. So I'll introduce you to the problem. It's a contiguous pile retaining wall has been designed. It supports compression, tension, moment, and lateral loading from a new bank seat. It accommodates the proposed link span bridge, and there were numerous site constraints within the site here. So solutions that you would normally consider, things like tie-back anchors and temporary propping, were not an option. So this was actually a project carried out in Dublin, and the proposed solution was a novel solution, and the solution was that it was proposed that they would simultaneously excavate both sides of the contiguous wall to 6 meters depth, and then they would construct a 2.5 meter wide concrete counterweight structure behind the wall. So it's a very different kind of problem. It's not a standard retaining wall, but Frew was still able to be used in this problem, and Frew was used to run serviceability analysis. So unfactored surcharge loads and soil were used to estimate the lateral deflection, the bending moments, and the shear forces. So if we go through the construction sequence here, you can see they're showing the capping beam construction. It goes on to show the simultaneous excavation of both sides of wall to formation level. And then it analyzes the construction of the counterweight structure. So here's the first layer of the counterweight structure and the completed counterweight structure with loading here, showing here for a moment, loading, there you go. So as you can see, it's quite an interesting analysis. It's very different to a normal standard retaining wall analysis. So I'm now going to go on to a different type of case study, and this is a case study that was carried out within Arab. And this is really a very good demonstration of how Frew can be used in conjunction with a lot of other pieces of software or Oasys software to look at a holistic retaining wall problem. And so I'm just going to start by introducing the problem. Now, this was the construction of the UCL hospital. And the UCL hospital was constructed in a densely populated urban area, and it was running very closely adjacent to a lot of buildings, in particular the Rain Institute. So the section of the retaining wall running alongside the Rain Institute had several restrictions. So one was just the proximity, really, and it was within 300 mil of the Rain Institute, and it was very close to the pile cap, as you can see to the left-hand side. But also there were requirements to locate a service lift there, and there were tight space restrictions that had to that went on to affect the wall thickness. So as you can see, it was a very interesting problem. And for this problem, in order not to undermine the basement of the adjacent Rain Institute building, it was proposed that the capping beam over the section of wall be raised above the new lower ground floor basement level. So this formed an upstand in the final condition, and it was proposed to construct a 600 mm diameter hard soft board secant pile wall with male piles at 750 mm diameter centers, and the smaller diameter of 600 mm in the area was required to be temporarily propped at 2 levels. So as you can see, there's a Frew run there showing how the analysis was carried out. But the analysis methodology was very interesting. So the iterative solutions were iterative methodology was actually used to calculate the effect of the movements on the Rain Institute piles due to excavation in front of the secant pile wall. And the Arab engineers commented on the compatibility between the software and the gateway system between all these four programs, which enabled the quick changes and convergence. So if we just look at this here, what was done by the Arab engineers was that they started with a Frew analysis, And out of the Frew analysis, they got the horizontal ground movements, which were applied within ALP on the Rain Institute piles. And then they got the vertical stresses, which were applied within pile to calculate the settlement and look at the settlement analysis. And then the vertical stresses went on to calculate the axial stress. So for example, from pile they got the axial stresses, and from ALP they got the moment, and these were fed into a sectional analysis, and this looked at a section of the pile in ADSEC. So once that section of pile was analyzed, the cracked value of EI was used to feed back into ALP, and so it was very iterative in its process, but very interesting analysis. So that's how you would run an overall retaining wall analysis, not only using Frew, but understanding the transverse loadings, understanding the effect of the settlement of the piles, and understanding the behavior of the pile themselves in a sectional capacity, using all the Oasys piling and retaining wall software. And this is actually covered previously in one of our webinars, which you might want to look at if you're interested. The final case study is of a very high-profile building, and this shows an example of how Frew is regularly being used for deep basement design. So really this could have been a case study for any one of a number of buildings built all over the country, but I'm just going to focus here on the Pinnacle, which is a very current project, and it's the development of a 62-story building in the City of London. The existing basements and ground levels across the site will be deepened, and a new site-wide basement is proposed to be constructed. The proposed building will be founded on a combination of piles founded in the London clay and Thanet sand strata. So Frew was used to design the hard firm secant pile retaining wall located at the southeast section of the site. The design was carried out in accordance with BS 8002 and Cirrus C580, and so it was carried out for the unfactored soil parameters, so an SLS analysis, and is carried out with factored soil parameters for the ULS analysis, or ultimate limit state analysis. The design methodology for vertical load considers both total and effective stress design. Shaft capacity is only assumed below the excavation level. So for the effective stress design, the input horizontal effective stresses are those calculated from the Frew retaining wall analysis. So because the wall is carrying vertical loading, wall friction may not be generated on the back of the wall, so therefore no benefit of the wall friction is taken on the active side of the Frew analysis, so that's why delta is taken to 0 there. So if we go into the analysis and have a look at the construction sequence within the wall that I mentioned, as you can see down to the southeast side, as you can see is highlighted down here with that bright blue line, we've got the wall, and a number of sections were taken through that wall, and the SLS and ULS runs were done for each of those sections. But if we look at one section, for example, I'm just going to run through the construction sequence. So here we've for stage 1, we've installed the wall and constructed the capping beam, excavated and installed the temporary prop, excavated and installed the second temporary prop, excavated to formation level, constructed the basement slab, removed the second temporary prop and construct the ground floor slab, remove this first temporary prop and construct the basement slab. So that gives you a good understanding of what's going on with the construction sequence. So now within Frew, I think it'll be very interesting for you to see how the analysis was done within Frew and the kind of results that you're getting. So I've just chosen this one specific section. So I've just chosen this one specific section here, and it's looking at the SLS analysis. So if you look, here's the initial condition, the installation of the wall, the excavation to ground floor slab, the excavation to basement level 2 slab, the excavation to basement level 3 slab, the construction of the slabs in the basement levels, basement level slabs and the ground floor slab, and then the long-term case. So what happens in the long term, and then the drain to undrained transition, or the undrained to drain transition in this case. So in summary, we've covered quite a lot here, and we've covered it very quickly. So we've covered the basic theory behind Frew. We've had a look at the inputs and outputs, and the modelling of effects in Frew. the EC7 limit state analysis, an introduction to it and how it would be applied in Frew. And then case studies showing how Frew has been used in industry, how it's used for just a general large basement project, and how it's used for non-standard projects. So now what next? After all this, you might be very interested to see what you can do with Frew and how you can use the more advanced modeling analysis, or maybe how you should apply EC7. Well, really you have to understand the Frew methodology, and a better look into the help file and the manual would be useful. Try the step-by-step examples. There are a number of previous webinars which are helpful and which cover Frew, show how to set up a model in Frew, show the graphical interface of Frew, and there are also, of course, the online tutorials for Frew. And support. The technical FAQs are very handy. They show you a lot of questions that have been asked by previous internal and external customers. And then there are, of course, online training movies. And please feel free to contact us. We're there. We're at the end of the email, at the end of a call. So please do call us if you have any queries or questions or want to understand how to better use Frew.